Good morning, children. Today we are going to learn about coefficient of variation. This is another method of finding out dispersion. This is another measure of finding out dispersion. Now this coefficient of variation is a relative measure of dispersion, not the absolute measure of dispersion. It is a relative measure of dispersion. It is used for comparing variability of two or more than two series. That means the variability in two and more than two series is found out with the help of coefficient of variation. If this is especially in case of two unequal mean. When the mean of two series is equal, then it is very easy to find out the variability. But if two series have unequal mean, then in that case it becomes difficult to find out the variation, and then we need to have the coefficient of variation. So this method is used for comparing variability of two or more than two series, especially in case of two unequal mean, right? So in this way coefficient of variation is used especially in case of two unequal mean. Next, coefficient of variation has been developed by Carl Pearson. Carl Pearson developed this concept of coefficient of variation. It shows the relationship between standard deviation and arithmetic mean expressed in percentage. So this is the formula: relationship between standard deviation divided by x bar, that is arithmetic mean, into 100. That gives you the percentage. Series having greater coefficient of variation, they are less uniform, less homogeneous and less consistent. When you are doing the calculation and the series shows greater degree of coefficient of variation, this means that two series are less uniform, less consistent or less homogeneous. That means there is great variation between the two, right? And if there is lesser CV, lesser coefficient of variation, this shows that the two series, what we are doing the calculation, two series are more uniform, more homogeneous and more consistent, right? This I will make it clear to you with the help of an example. So this is that if coefficient is greater, it shows less consistency or less uniform, and if it is less, this shows more uniformity and more consistency, right? Now this is the formula for coefficient of variation. CV is equal to standard deviation upon mean into 100. As I told you here, it shows the relationship between standard deviation and arithmetic mean expressed in percentage. So standard deviation upon arithmetic mean expressed in percentage. This is the formula of coefficient of variation. Okay, now let us take the example of two series to make it clear to you how do we do the calculations, right? Now this is the example. Here I have given you the scores of two batsmen A and B, and the scores are as follows. A has scored these many points and B has scored this data, right? Now we will take the calculation, how it is calculated. Now let us do the calculation. This is the case of individual series, batsman A and batsman B. The data or the score given are copied down here. This is the x column, copy down the data. Now take out the mean. Total of x column is 460, x bar is equal to sigma x upon n, that is 460 upon 10, that is equal to 46. So mean you have got 46, x bar is 46, x minus x bar is minus 14, 32 minus 46, 28 minus 46, like this you will get these figures. Add up all minus and add up all plus, you will get sigma dx square is equal to 0. Now third column you will make the square of dx column. How do you make the square? that is 14 into 14 is 196, 18 into 18 is 324. So like this you will multiply 25 and 17 into 17, 25 into 25, and you will get this data. Add up this column, that is sigma dx square, and that is 6500, right? Now next step is find out standard deviation, because your formula for CV says standard deviation upon x bar into 100. So standard deviation is sigma dx square upon n whole under root. Sigma dx square is 6500 upon n is 10. This is whole under root, that is equal to 650 under root, and that is equal to 25.5. This is your standard deviation for batsman A, right? Now next step is to find out the coefficient of variation. CV is equal to standard deviation upon, this is x bar into 100, 25.5 is standard deviation, x bar is 46, 25.5 into divided by 46 into 100, and you will get this as coefficient of variation, that is 55.43, and this is the data or coefficient of variation for batsman A, right? Now let us find out what is the CV of batsman B, and then we can do the comparison. Now batsman B, here I have taken it as y bar. Now data is copied down again, total is done, that is sigma y is equal to 500. Now let us see what is the mean. Sigma y upon n is number of items, sigma y is 500, 500 upon 10 is equal to 50. So y minus y bar will be 19 minus 50, 31 minus 50, 48 minus 50, like this you get the data. Add up this column, this is 0, make a square of this column as you have done in this case. 31 into 31 is 961, 19 into 19 is 361, like this. Make a square of this dx column or dy column, this will be dy square. Add up this data, total is 5968. So standard deviation is sigma dy square upon n, 59, this is 5968 upon 10 is equal to 596.8 is equal to 24.43. This is the standard deviation. Now you have to find out coefficient of variation, right? Sigma, this is standard deviation upon y into 100. Standard deviation is 24.43 upon y. Y is this is y bar, right? 4 upon 3, y bar is 50. 50 is the mean. For 24.43 upon 50 into 100, and this is 48.86. So CV of batsman A was 55.43, batsman B was 48.86. B is more consistent because there is less coefficient of variation. As I told you, if coefficient of variation is less, that means it is more consistent. So in this case, comparing these two batsmen, 48.86, this is the lower figure, so B is more consistent because less coefficient of variation. So in this way, mean of two series were different, and in this way we can compare the consistency or variability of two type of series. And if CV is less, then this shows this is more consistent, and if it is more, it shows less consistent. This one is less consistent and this one is more consistent, right? So this is the case of individual series. Now we will take the calculation of coefficient of variation in the next type of series, that is discrete series. This is the case of discrete series. item and frequency is given. You know frequency is given in the case of discrete series. This is the data given to you. You are supposed to calculate coefficient of variation. These are the steps what you are supposed to follow. Copy down X column, that is item, copy down frequency, the same order, right? Do the total of frequency column, that is N or sigma F is equal to 50. Now take the assumed mean. Here assumed mean we have taken as 16. Take out the deviation from assumed mean. dx is equal to x minus a. A is the assumed mean. 10 minus 16 is minus 6. 12 minus 16 is minus 4. 14 minus 16 is minus 2. Like this you get the data. Now f dx column you need, because your formula for assumed mean is this one. You need f dx and f dx square. F dx you know clearly, this is dx column, and dx multiplied by f becomes f dx. Dx is x minus a, f is frequency. Dx multiplied by f is f dx. This is the data. Now multiply minus 6 into 4, minus 24. 6 into minus 4 is minus 24. 10 into minus 2 is minus 20, and so on. Total of this column is minus 22. Minus side is bigger, so it is minus 22. Now f dx square, you don't have to make the square of this column, you have to make the square of dx and multiply it by this. So you will get this data, right? F dx square, that is 452. After getting this data, you apply the formula. First, because you have calculated f dx, let us see what is actual mean. Why do we have to calculate actual mean? Because for CV, coefficient of variation, you need actual mean. It is SD upon x bar into 100. So a plus sigma f dx is minus 22. A is 16 we have taken, minus 22 upon 50 is equal to, this is assumed mean, right? Now we will find out the standard deviation. Write down the formula. Sigma f dx square is 452 upon 50 minus sigma f dx is minus 20 upon 50 whole square whole under root. Simplify this, and this is the standard deviation, 2.97. And for coefficient, standard deviation upon n into 100, 2.97 upon n, this is x bar, sigma standard deviation upon mean into 100, mean is 15.56. So 2.97, this standard deviation upon x bar 15.56 into 100, and coefficient of variation is 19. This is your answer for discrete series, right? And in the case of continuous series, same steps can be followed after taking out the mid values of the class interval, as you have done earlier also. You know how to calculate the mid values. First calculate the mid values, then you will get x column and f is given to you. Follow the same steps after calculating the mid values, and you get the answer. Okay. Now these three types of series we have done. Let us see now what is the relationship between QD, SD and MD. These three deviations are, or these three measures of dispersion are correlated. So these are related to each other. Let us see the relationship. Relationship among various measures of dispersion. First is QD is 2/3 of SD. That is SD is equal to 3 upon 2 of QD. You have to learn this. This whole you have to learn. MD is equal to 4 upon 5th of SD. That is SD standard deviation is equal to 5 upon 4 MD. QD is 5 upon 6 of MD, that is MD is equal to 6 upon 5 QD. Now let us take the example. calculate MD and QD if SD is 80. Now this is the first example, calculate MD and QD if SD is 80. Now here MD, you know, MD is 4, 5 of SD, right? And SD is 80 over here, so it is 4 upon 5 into 80, and this is MD if SD is 64. Same way QD is equal to 2/3 of SD is equal to 2/3 of SD is 80 given to you, right? So 2/3 of 80, and this is QD. So if one is given, either SD, MD or QD, one is given, you can find out the other two because there is a relationship. SD, second one, calculate SD and QD if MD is 90. SD is equal to 5 upon 4, right, of MD. Now SD is 5 upon 4 of MD, you know, it is given here. 5 upon 4 of MD, MD is 90, 5 upon 4 of 90, and this is SD. Now let us see, because MD is given, let us see what is QD. QD is 5 upon 6 of MD is equal to 5 upon 6 into 90, MD is 90 and QD is 75. So here MD was given to you and you could calculate SD and QD, or QD is equal to 2/3 upon SD is equal to 2/3 into SD is given, this one is SD, and then QD is 75. Now third, calculate SD and MD if QD is 60. SD is equal to 3 upon 2 QD. SD is equal to 3 upon 2 QD, right? 3 upon 2 into QD is 60. So 3 upon 2 into 60 is equal to 90. And what is MD? MD is 4 upon 5 of SD. MD is 4 upon 5 of SD. So MD is equal to 4 upon 5 of SD is equal to 4 upon 5 into 90. SD is 90 given to you, and it is this is SD, you have calculated 90, and so this is 90 is equal to 72, or MD is 6 upon 5 of QD is equal to 6 upon 5 into 60. QD is 60, 6 upon 5 into 60 is equal to 72. So this way you can see that there is a relationship. If one is given to you, you know that in what ratio you can calculate the other two. So in this way there is a relationship between QD, SD and MD. All three are related to each other, right? So this completes your calculation of coefficient of variation.